Is it now erupted? And Earth's electromagnetic heartbeat changed. A 25 Hz frequency erupted from nowhere, impossibly clean, sustained, and perfectly timed with interstellar object 3I Atlas's closest approach to our planet Earth. Not hours off. Exact synchronization across 270 million kilometers of void. This isn't supposed to happen. Comets don't reach across space and make atmospheres sing new songs. Yet multiple stations worldwide recorded the same anomaly. A massive spike dominating the Schumann resonance spectrum, appearing as the object transformed at perihelion, then fading as it departed. The physics don't explain it, the models don't predict it, but the data is undeniable. Something responded to something else. Before we go deeper into what this means, before we examine the implications of Earth responding to an interstellar visitor in ways that conventional physics doesn't predict, you need to understand something. The story is still unfolding. Right now, as you're reading this, 3I Atlas is racing toward its next encounter. On March 16th, 2026, it will make a close pass by Jupiter at a distance of just 53 million kilometers. That's extraordinarily close for a random interstellar object. Threading past Earth and then threading past Jupiter isn't coincidence, it's precision. If you want to follow this investigation as it develops, if you want to understand what happens when the object reaches Jupiter, and whether the patterns we're seeing at Earth repeat at the solar system's largest planet, hit that subscribe button now and turn on notifications, because the data coming in over the next 3 months might fundamentally change how we understand interstellar visitors and what they're capable of. You don't want to miss what happens when a mysterious object with anomalous properties enters the most intense radiation and magnetic field environment in the solar system. The official story from NASA and ESA has been measured and cautious. 3I Atlas is an interesting interstellar comet. Its closest approach was safe. The flyby provided valuable observational opportunities. Nothing to worry about. Just another visitor from the deep void, passing through our neighborhood on its way back to interstellar space. But that official story is starting to crack. Because while the agencies were focused on tracking the object's trajectory and collecting spectroscopic data, something else was happening. Something terrestrial. Something that suggests the interaction between 3I Atlas and Earth went beyond simple gravitational mechanics. The first report came from a researcher known in the community as All-Day Astronom. Not a professional scientist with institutional backing, just a dedicated enthusiast with the right equipment and the awareness to be looking at the right thing at the right time. He'd been monitoring the Schumann resonance as a hobby, tracking Earth's electromagnetic baseline the way some people track weather, patterns, or seismic activity. On December 19th, his instruments went crazy. The spectrogram, the visual representation of frequency distribution over time, showed something unprecedented. The normal 783 Hz fundamental was there, steady as always. The harmonics at 14 and 20 Hz were visible but faint as expected, and then, towering above everything else, a massive peak at 25 Hz. He checked his equipment, recalibrated, looked for interference sources, radio transmissions, power line noise, HARP activity, anything that might explain an artificial signal at that frequency. But the signal wasn't artificial in the sense of being human-made. It was coming from Earth's atmosphere, from the ionospheric cavity, and it was real. Within hours, other monitoring stations confirmed it. Not just one isolated instrument having a malfunction, multiple independent systems, scattered across different continents, all seeing the same thing. A 25 Hz signal that appeared at the moment of closest approach, sustained for several hours, then gradually faded as 3I Atlas moved away. The correlation was undeniable, the timing was exact, and the conventional explanations fell apart under scrutiny. Lightning activity was normal that day, no exceptional storms that might account for unusual resonance patterns. Global thunderstorm activity, which drives the Schumann resonance, was within typical parameters. If anything, it was a quiet day electromagnetically, which makes the 25 Hz spike even more inexplicable. HARP, the high-frequency active auroral research program that conspiracy theorists love to blame for everything from earthquakes to mind control, wasn't operating at frequencies that would produce this signal. The transmission logs are public. Nothing matches. Tectonic activity? Earthquakes can sometimes produce electromagnetic precursors, subtle changes in Earth's field before the rocks actually break. But there were no significant earthquakes on December 19th. No seismic events that correlate with the signal's appearance or duration. Solar activity, coronal mass ejections and solar wind variations can affect Earth's magnetosphere and, by extension, the ionospheric cavity. But the Sun was relatively quiet. No major eruptions, no geomagnetic storms. The solar data doesn't explain the signal, which leaves us with the uncomfortable reality that the only unusual event on December 19th was the passage of 3I Atlas. And the signal appeared when the object was at its closest point, not approaching, not receding, at the exact moment of perihelion relative to Earth. That's not how comets work. A standard ball of ice and rock doesn't create electromagnetic signatures detectable from 270 million kilometers. It doesn't interact with planetary ionospheres in ways that change the fundamental resonance patterns. The physics simply don't support it. Unless the object isn't standard, unless there's something about 3I Atlas that makes it capable of interactions we don't normally see. Something that lets it reach across the void and touch Earth's electromagnetic field in measurable ways. The natural explanation, the one that conventional science wants to embrace, is that we're witnessing an unknown but ultimately explicable phenomenon. That interstellar comets, having spent millions of years in the deep cold of interstellar space, accumulate charges or develop plasma environments that we don't see in solar system comets. That the interaction with Earth's magnetosphere as 3I Atlas passed by created conditions we haven't observed before, because we've only seen 3 interstellar visitors total, and our sample size is pathetically small. It's plausible. It fits within the framework of natural processes. It doesn't require invoking anything extraordinary, just unusual circumstances producing unusual results. But there's a problem with that explanation. The signal wasn't random noise. It wasn't chaotic electromagnetic activity that happened to peak around 25 Hz due to atmospheric resonance conditions. The signal had structure. It had periodicity, and that periodicity matched something specific about the object itself. Observers tracking 3I Atlas had established its rotation period weeks before closest approach. The object brightens and dims in a regular cycle, as different parts of its surface reflect sunlight toward Earth. That cycle, that pulsation period, had been measured at approximately 16.16 hours. One complete rotation every 16 hours and 10 minutes or so, steady, predictable, the kind of data point you can set your clock by, until December 19th, until closest approach, until Earth started humming at 25 Hz. Because at that exact moment 3I Atlas changed its rhythm. The rotation period that had been 16.16 hours suddenly became 15.48 hours. The object sped up, it shaved 41 minutes off its day in a matter of hours, and the 25 Hz signal, when you analyze its fine structure, when you look at how it modulated over time, shows patterns that correlate with that new rotation period. The signal wasn't just turning on and off, it was pulsing, breathing, tracking the rotation of the object as if whatever was creating the signal was physically coupled to the surface of 3I Atlas. That coupling is what makes this impossible to dismiss as coincidence. If the electromagnetic signal and the rotation change were unrelated, if they just happened to occur at the same time by chance, you wouldn't expect to see correlations in their temporal structure. But the correlations are there. The signal tracks the spin, which means whatever caused the spin change also caused the signal, or both were caused by something else, some process or mechanism operating on or within the object. The implications are staggering, because changing the rotation rate of a multi-kilometer object requires energy, enormous energy. Angular momentum is conserved in physics. You don't just start spinning faster unless you shed mass or apply torque. For 3I Atlas to spin up by 41 minutes, to accelerate its rotation that dramatically in such a short time window, something massive had to happen. Comets can change their spin through outgassing. As ice sublimes and turns to gas, it escapes from the surface, acting like tiny rocket engines. If the jets are asymmetric, if they're venting preferentially from one side or one hemisphere, they create torque. Over time, that torque can spin up the nucleus or spin it down or change its rotational axis. This is well understood physics. We've observed it in many comets. But the outgassing required to change the spin this much this fast would be cataclysmic. it would create a massive visible coma. The nucleus would brighten dramatically as all that gas and dust poured into space. We'd see jets, structures in the coma, clear evidence of violent activity. We saw none of that. The brightness of 3I Atlas remained relatively stable during the spin-up event. No dramatic increase in coma size, no obvious jets. The object looked, from a distance, remarkably unchanged even as its rotation accelerated to rates that conventional outgassing models can't explain. So what applied the torque? What pushed 3I Atlas into faster rotation? What mechanism could operate without producing the visible signatures we associate with cometary activity? This is where the conversation shifts from astrophysics to something that makes most scientists deeply uncomfortable. Because if you eliminate natural outgassing, if the conventional explanation doesn't fit the data, you're left with alternatives that sound like science fiction. Avi Loeb, the Harvard astrophysicist who's made a career out of taking the possibility of extraterrestrial technology seriously, has been vocal about this case. His argument is straightforward. When natural explanations require increasingly contrived scenarios, when you have to stack coincidence on top of coincidence to make the data fit, maybe it's time to consider that the object isn't natural. Loeb has proposed that the rotation change could be the result of active maneuvering, that 3I Atlas might have engines or propulsion systems that fired during closest approach to Earth, executing a course correction or orientation change, that the spin-up wasn't passive outgassing but active thrust, and that the 25 Hz electromagnetic signature was a byproduct of that propulsion system operating, energy leaking into Earth's ionosphere as the object powered up. It's a bold hypothesis, extraordinary in the Sagan sense, the kind of claim that requires extraordinary evidence, and Loeb acknowledges that the evidence isn't definitive. But he argues, compellingly, that the evidence is suggestive enough that dismissing the artificial hypothesis out of hand is itself unscientific, that we should be actively testing this possibility rather than assuming it away. The mainstream pushback has been fierce. Critics argue that Loeb is sensationalizing ambiguous data, that he's making the same logical error ancient astronaut theorists make when they see straight lines on Mars and call them roads, that with enough creative interpretation you can make any unusual observation look like technology. And they're not wrong. Human pattern recognition is powerful but prone to false positives. We see faces in clouds and conspiracies and coincidences because our brains are wired to find meaningful patterns even in random noise. The burden of proof for claiming artificial origin is rightfully high because the implications are so profound. But here's where the argument gets interesting. The critics demanding natural explanations haven't provided convincing ones. The outgassing model doesn't work without visible jets. The fragmentation model, where internal shifting of mass changes the moment of inertia and causes spin-up, doesn't explain the stability of the object or the electromagnetic signal. The exotic materials model, where 3I Atlas might be composed of ices with unusual sublimation properties that create invisible jets, is pure speculation with no supporting evidence. Every natural explanation being proposed requires assuming things about the object that we have no reason to assume, requires invoking circumstances that are themselves extraordinary. At some point, you have to ask whether the extraordinary natural explanations are actually more plausible than the extraordinary artificial explanation, especially when you look at the full context, the rotation change, the electromagnetic signal, the timing, and now the visual evidence that's emerged from high-resolution imaging during the spin-up event. Because while Earth was humming and the object was accelerating its rotation, telescopes were capturing images, multiple facilities, different instruments, various wavelengths. And when researchers processed those images, when they stacked and enhanced the frames to pull out maximum detail, they saw something that has never been documented in any comet in the history of astronomy. A dark core, a void, a perfectly centered region of blackness surrounded by a luminous ring. Standard comets don't look like that. The nucleus should be the brightest point, solid material reflecting sunlight. The coma should be a diffuse cloud surrounding it, gas and dust scattering light in all directions. What you should see is a bright central condensation fading gradually into fainter outer regions. What 3I Atlas showed was the inverse. The center was dark, absorbing light rather than reflecting it, and around that darkness a sharp, geometrically precise ring of luminosity. Not a fuzzy halo, not scattered light, a ring, a torus, like looking down the barrel of a massive engine or into the eye of something ancient and watchful. The shape is wrong. The geometry is wrong. The photometry is wrong. Everything about this image contradicts what we know about how comets work and how they should appear. Some researchers are arguing it's an optical illusion, a shadow effect created by the object's unusual shape and rotation. Maybe 3-eye atlas is a contact binary, 2 lobes touching, and we're seeing one lobe casting a shadow on the other. Maybe the dust distribution is creating a temporary obscuration of the central region, while light scatters from the edges. But the symmetry argues against that. Shadows from irregular objects are irregular. They shift and change as the object rotates. The dark core of 3-eye atlas is centered, stable, persistent across multiple observation sessions. Whatever is causing it isn't a transient shadow, it's a structural feature. The alternative interpretation, the one that the artificial origin proponents are running with, is that we're looking at exactly what it appears to be. A hollow object, a shell, a constructed hull with a central void and a luminous rim that could be radiating heat from internal systems or venting material from the edges. If 3-eye atlas is hollow, it can't be natural. Gravity doesn't build hollow structures. Nature accumulates mass into solid bodies, irregular lumps and spheres depending on size and composition. Hollow shells require engineering, require intention, require minds that design and build. The physics of a hollow object also explains some of the other anomalies. If the mass is concentrated in a shell rather than distributed throughout a solid body, the moment of inertia is different. Changes in rotation become easier to achieve with less torque. And if material is being vented from the rim rather than the entire surface, you could have vigorous activity without a visible coma surrounding the nucleus. The luminous ring could be propulsion exhaust. The dark core could be the non-reflective interior of the shell, empty space or machinery that doesn't scatter sunlight the way ice and rock do. And the 25 Hz signal could be electromagnetic leakage from whatever systems are operating inside that shell, energy that couples to Earth's ionosphere and creates resonance. It all fits together. Disturbingly well. Every piece of the puzzle slots into place if you accept the premise that 3-eye atlas is artificial. The rotation change becomes a maneuver. The electromagnetic signal becomes operational leakage. The dark core becomes structural evidence. The trajectory becomes navigation. But accepting that premise means accepting that we're not alone, that something built by non-human intelligence has entered our solar system, approached our planet, and is now heading toward Jupiter before leaving. That we're being visited, studied, perhaps even catalogued. The psychological weight of that conclusion is heavy. It changes everything. Our place in the cosmos, our assumptions about the prevalence of intelligence, our understanding of what's possible and what's happening in the galaxy we inhabit, which is why the scientific establishment is resisting it so hard. Not out of closed-mindedness, though some critics claim that, but out of appropriate caution. Because being wrong about this, claiming artificial origin, when the object is actually natural, would be embarrassing, would damage credibility, would give ammunition to every conspiracy theorist and pseudoscientist who claims that mainstream science suppresses inconvenient truths. Better to be conservative, to demand overwhelming proof, to exhaust every possible natural explanation before even considering the extraordinary one. That's how science protects itself from false positives and premature conclusions. But at what point does appropriate caution become willful blindness? At what point does the accumulation of anomalies reach a threshold where the artificial hypothesis deserves serious consideration rather than knee-jerk dismissal? We might be at that point. With 3-eye atlas, we might be facing a situation where the conventional frameworks simply don't work, where the object is too strange, the behaviours too anomalous, the coincidences too numerous to explain away with natural mechanisms. Or we might be seeing exactly what we want to see, reading meaning into randomness, constructing narratives from noise, falling into the ancient human trap of mistaking the unknown for the designed. The truth is we don't know yet. The data is ambiguous, the observations are incomplete, and the questions we're asking are so fundamental, so laden with implication, that answering them requires more than just a few weeks of telescope time. But we do know some things. We know that on December 19th, 2025, Earth's electromagnetic field responded to the presence of an interstellar visitor in ways that have no precedent in the observational record. We know that the object's rotation changed at exactly that moment, accelerating in a manner inconsistent with passive outgassing. We know that images show a dark core and luminous ring that don't match any natural comet we've ever studied. And we know that the object is heading toward Jupiter, not drifting randomly, not following a purely gravitational trajectory, but threading the needle again, passing within 53 million kilometers of the solar system's largest planet in a geometry that looks less like chance and more like a scheduled stop. The Jupiter encounter is going to be crucial. It's the next test. If 3I Atlas behaves like a rock, if it follows a predictable orbit and shows no further anomalies, we can start to relax. Start to believe that we've just witnessed unusual natural phenomena that we'll eventually explain once we've studied more interstellar visitors and expanded our models. But if the object does something at Jupiter, if it changes course again, if it spins up or slows down or emits signals or exhibits any behavior inconsistent with a passive chunk of ice and rock being pulled by gravity, then the conversation changes. Then we have to seriously confront the possibility that we're watching something intelligent, something deliberate, something that's here for a reason. The time between now and March 16th is a waiting period, a breath held, a moment of uncertainty before the next data point arrives and either resolves the mystery or deepens it beyond recognition. But while we wait, we can examine what we already know. We can dig deeper into the rotation anomaly and what it tells us about the object's internal structure. We can analyze the electromagnetic signature and compare it to known natural and artificial sources. We can model trajectories and calculate probabilities and test whether the Jupiter flyby is genuinely unlikely or just appears that way because we don't have good statistical baselines for interstellar visitor behavior. The work continues, the observations accumulate, and the debate intensifies. Because 3I Atlas has done something no other interstellar object has done. It's made Earth respond. It's created a measurable, undeniable interaction between a visitor from the stars and our home planet. And whether that interaction is natural or artificial, whether it's coincidence or contact, it's changed how we think about what's possible when objects from other stellar systems pass through our neighborhood. The 25 Hz signal is fading now. As the object moves away, as the distance increases, and whatever coupling existed between 3I Atlas and Earth's ionosphere weakens, the electromagnetic anomaly is returning to baseline. The Schumann resonance is settling back into its normal pattern. 7.83 Hz fundamental, faint harmonics, the heartbeat of Earth returning to its ancient rhythm. But the signal was there, it happened. Multiple independent instruments recorded it, and the correlation with the object's closest approach is documented fact, not speculation or interpretation. That fact alone is enough to justify continued scrutiny, enough to warrant taking seriously the possibility that something extraordinary occurred, enough to make the Jupiter encounter absolutely critical for understanding what we're actually dealing with. Because if the pattern repeats, if 3I Atlas approaches Jupiter and Earth's ionosphere responds again, if the electromagnetic coupling extends across the solar system in ways that shouldn't be possible for natural objects, then we'll know. We'll have confirmation that this isn't coincidence, that there's a real, measurable, repeatable interaction happening. Or if nothing happens at Jupiter, if the object passes by without any terrestrial response, without any electromagnetic signatures, without any further anomalies, then maybe we can breathe easy. Maybe we can accept that December 19th was a fluke, a rare confluence of circumstances that created the appearance of connection where none actually existed. Either way, we'll know more in 3 months. Either way, the story of 3I Atlas will have advanced from ambiguous data to clearer conclusions. But there's another aspect of this mystery that we haven't fully explored yet. The rotation change itself. The mechanism by which a multi-kilometre object accelerated its spin by 41 minutes in a matter of hours. Because that's not just unusual, it's physically demanding in ways that challenge our understanding of what comets can do. To appreciate why the spin-up is so problematic, you need to understand angular momentum. It's one of the most fundamental conservation laws in physics. An object's rotational energy depends on how fast it's spinning and how that mass is distributed. Change the distribution, pull mass toward the center like a figure skater pulling in their arms, and you spin faster. Shed mass asymmetrically, like a Catherine wheel firework, and you can change your rotation through reaction forces. But both mechanisms have signatures. Both produce observable effects. If 3I Atlas was shedding mass to create torque, we'd see that mass. We'd see jets, streams of material leaving the surface and creating reaction thrust. If it was somehow compacting, Changing its shape to alter its moment of inertia, we'd see the structure deform. We'd see the object becoming more spherical or elongating depending on how the mass was redistributing. We're seeing neither. The object appears structurally stable. Its brightness hasn't changed in ways consistent with massive material loss, and yet its rotation accelerated dramatically. The energy budget is the real problem. Spin-up requires work, requires energy input. Where's that energy coming from? Solar heating is too weak at 270 million kilometers to drive the kind of outgassing that would be needed. And even if it were strong enough, outgassing creates visible signatures, brightness changes, coma development, tail formation, none of which match the observations. Internal energy sources, radioactive decay, tidal heating. These are mechanisms that work inside planets and large moons. They don't operate on kilometre-scale objects made of ice and rock. The heat generation would be negligible, not enough to drive the rapid changes we're seeing. Chemical reactions, maybe some exotic chemistry we don't understand, ices that aren't water or carbon dioxide, but something that sublimes differently or releases energy through phase changes we haven't considered. Possible, but speculative. And again, where are the visible products? Where's the gas and dust that should accompany such reactions? Every natural energy source we can think of either isn't strong enough or doesn't match the observational constraints. Which brings us back to the uncomfortable alternative, that the energy is coming from inside the object, from systems we don't recognize because they're not natural, from propulsion or power generation or whatever mechanisms an artificial probe would use to maintain itself and execute maneuvers. If the object has engines, if it's capable of generating thrust, then spinning up becomes trivial. Fire the engines in a specific configuration, create torque, change your rotation. The energy comes from stored reserves, fuel or battery equivalents or exotic power sources that don't require ongoing external input. And the exhaust, if it's directed properly, might not create the kind of visible coma we associate with cometary outgassing. It fits. It explains the rapid spin-up without requiring visible mass loss. It explains the stability of the structure under rotational stress. It explains the timing, why the maneuver happened at closest approach to Earth rather than at some random point in the trajectory. But it requires accepting that we're looking at technology, that the object was built, that somewhere out there, intelligence exists that's capable of crossing interstellar space and visiting other stellar systems. The mainstream scientific response to this line of reasoning is predictable. Extraordinary claims require extraordinary evidence. We don't have extraordinary evidence, we have ambiguous observations that could potentially be explained naturally if we expand our models and consider scenarios we haven't fully explored yet. And they're right to demand more proof. Science isn't about jumping to exciting conclusions. It's about building cases carefully, testing hypotheses rigorously, eliminating alternatives systematically. The burden of proof for artificial origin is appropriately high, but the counter-argument is equally valid. At what point does refusing to consider the artificial hypothesis become a form of bias? At what point does demanding impossible levels of proof become a way of avoiding uncomfortable possibilities? If 3I Atlas were unambiguously natural, if it looked and behaved like every other comet we've studied, there wouldn't be a debate. We'd catalogue it, add it to the database of interstellar visitors, and move on. The fact that there is a debate, that serious researchers are taking the artificial hypothesis seriously, even if they ultimately reject it, tells you something about how unusual the observations are. The dark core, the rotation anomaly, the electromagnetic signal, the trajectory precision. Each individual piece might be explicable, might have some convoluted natural explanation that requires special circumstances but doesn't violate physics. But when you put them all together, when you see the pattern of anomalies clustering around a single object, the cumulative improbability starts to exceed the improbability of the artificial hypothesis itself. This is Bayesian reasoning, updating your beliefs based on accumulating evidence. If your prior probability for artificial visitors is very low, it takes a lot of evidence to shift that probability upward. But at some point, if the evidence keeps coming, if each new observation makes the natural explanations more strained, you have to update. You have to acknowledge that maybe, just maybe, the extraordinary explanation deserves serious consideration. We might not be there yet with 3I Atlas. The evidence might not be strong enough. The observations might still fall within the range of weird but natural, rather than crossing into probably artificial. But we're close. Closer than we've ever been with any previous astronomical observation. Closer than with Oumuamua, which had its own anomalies but nothing as dramatic as a 25 Hz electromagnetic signal, or a 41-minute rotation change, or a dark core surrounded by a luminous ring. And the Jupiter encounter will push us over the threshold or pull us back. Will either provide the extraordinary evidence that extraordinary claims require, or will demonstrate that all the anomalies have natural explanations once we observe them in different contexts. The waiting is difficult. 3 months feels like an eternity when you're dealing with questions this fundamental. But the universe operates on its own schedule. 3I Atlas is moving at 58 kilometers per second relative to the Sun. It will reach Jupiter when it reaches Jupiter, and not a moment sooner. In the meantime, we prepare. We point every available instrument at the object's trajectory. We model what should happen during the Jupiter flyby based on gravitational mechanics. We predict what the electromagnetic environment around Jupiter will do to the object if there's any coupling similar to what we saw at Earth. We prepare observation campaigns and data collection protocols and analysis pipelines. Because when March 16th arrives, we need to be ready. Ready to capture everything. Ready to measure precisely. Ready to either confirm our suspicions or lay them to rest. The story of 3I Atlas is far from over. We're in the middle chapters. The setup has been established. The anomalies have been documented. And now we're building toward the climax, the moment when either everything makes sense or nothing does. What happens at Jupiter will determine which path we're on. Whether we're witnessing a genuinely extraordinary event, the passage of something artificial through our solar system, or whether we're experiencing the growing pains of a young species learning that the universe is stranger and more diverse than our limited experience suggested, but ultimately still governed by natural laws that we'll eventually understand. Either answer would be profound. Either answer would change us, but only one of them would change everything. The dark core stares, the luminous ring glows, the rotation accelerates, and Earth's electromagnetic field hums a frequency that shouldn't exist, a tone that emerged from nothing and will haunt our observations until we understand what created it. 25 Hz, the number we'll remember, the frequency that marks December 19th, 2025 as a date when something happened that we can't fully explain. When an object from the stars made our planet respond in ways we've never documented before. And the object continues its journey, indifferent to our curiosity, heading toward the giant planet with precision that looks less random with every calculation we run, threading the needle again, passing close to Jupiter in a geometry that would be impressive if it were planned and extraordinary if it's chance. We'll know soon. 3 months. Just 3 months until the next data point, until the next test, until we see whether the pattern holds or breaks, and while we wait, the dark core continues to stare. The rotation continues to stabilize at its new, faster rate, and somewhere in the void, 58 kilometers closer to Jupiter every second, 3I Atlas carries its secrets toward the next encounter. The heartbeat changed. Earth responded, and now we watch and wonder what will happen when the visitor reaches the king of planets and enters an environment where the electromagnetic forces are thousands of times stronger than anything Earth can produce. If there's coupling, if there's interaction, if Jupiter's massive magnetosphere responds the way Earth's ionosphere did, the signals will be unmistakable, the evidence will be overwhelming, and the debate will end, replaced by the far more difficult conversation about what it means to share the galaxy with others. But if silence, if nothing, if the object passes by Jupiter as just another rock following gravity's pull, then maybe we can breathe. Maybe we can accept that we saw something unusual but ultimately natural. That the universe surprised us but didn't fundamentally challenge our understanding of our place in it. 3 months to wait. 3 months to wonder. 3 months until the dark core either reveals its nature or keeps its secrets forever. The signal fades. The rotation stabilizes. The object speeds onward. And we remain, changed by what we've seen, uncertain about what it means, waiting for the universe to provide answers to questions we've been asking since we first looked up at the stars and wondered if anyone was looking back. The mathematics of the trajectory don't lie. When you calculate the orbital mechanics of an object entering the solar system from interstellar space, when you trace its path through the gravitational wells of the Sun and planets, you get probabilities, statistics, likelihood distributions for where it should go and what it should encounter, And according to those calculations, the probability of 3I Atlas passing within close range of both Earth and Jupiter on a single trajectory is vanishingly small, not impossible. Space is governed by physics, not magic, and any trajectory that doesn't violate conservation laws is technically possible, but unlikely, extraordinarily unlikely. Threading past Earth at 270 million kilometers is one thing. That's a safe distance, comfortable, the kind of flyby that happens occasionally with long-period comets and asteroids, but then continuing on that same trajectory and passing within 53 million kilometers of Jupiter 3 months later. That's precision. That's threading two needles with a single thread. The geometry required is specific, particular. The kind of configuration that happens by chance maybe once in a million random interstellar trajectories. Unless it's not random. Unless the trajectory was planned. Unless 3I Atlas is navigating rather than drifting. The implications of that possibility are staggering, because navigation requires intention, requires systems capable of detecting planetary positions and calculating approach vectors, requires propulsion to make course corrections, requires purpose, a mission, a reason for being here that goes beyond simple gravitational capture. If 3I Atlas is navigating, then every assumption we've made about it being a natural comet collapses. Natural objects don't navigate, they fall. They follow trajectories determined by initial conditions and gravitational influences. They're passengers, not pilots. A comet that can steer is by definition not just a comet. But proving navigation is difficult, because you need to demonstrate that the trajectory deviates from what gravity alone would produce. You need to measure non-gravitational accelerations with enough precision to rule out random outgassing and other natural effects. And you need to show that those accelerations are directed, purposeful, aimed at achieving specific geometric configurations rather than being random perturbations. The rotation change on December 19th might be evidence of exactly that. If the spin-up was caused by thrust, if it was a maneuver rather than natural outgassing, then it should have affected the trajectory. Firing engines to create torque doesn't just change rotation, it changes velocity, alters the orbit, creates deviations from the predicted path. Researchers are looking for those deviations now. Comparing observations from before and after the closest approach to Earth, measuring the object's position with extreme precision, calculating whether its actual path matches the predictions from gravitational models, or whether there are residuals, unexplained offsets that suggest non-gravitational forces were operating. The preliminary results are ambiguous. There might be small deviations, tiny offsets in the predicted versus observed positions that could indicate thrust, but the uncertainties are large. The measurements aren't precise enough yet to say definitively whether those offsets are real or just noise, random errors in the observations that create the illusion of deviations when none actually exist. By the time 3I Atlas reaches Jupiter, we'll have much better data. 3 months of additional tracking, hundreds of observations from multiple telescopes. Orbital solutions refined to the point where gravitational predictions are accurate to within kilometers. And if there are deviations, if the object's path shows systematic offsets that can't be explained by gravity and random outgassing, we'll know. We'll have quantitative evidence that something is steering, but even without that evidence yet, the Jupiter flyby itself is telling. Because the geometry is so specific, the timing is so precise. 53 million kilometers on March 16th, 2026. That's not just close, that's targeted, like the object knew Jupiter would be there and adjusted its path to intercept. Of course, you could argue that Jupiter's gravity well is enormous, that it captures and deflects objects all the time, that any interstellar visitor passing through the inner solar system has a reasonable probability of having a close encounter with the largest planet, simply because it dominates so much of the gravitational landscape, and that argument has merit. Jupiter is the vacuum cleaner of the solar system. It hoovers up comets and asteroids that would otherwise threaten Earth. Its gravitational influence extends across vast regions of space, but 3I Atlas was already on a trajectory to leave the solar system after passing Earth. Its hyperbolic excess velocity was sufficient to escape the Sun's gravity without any additional boost. It didn't need to go to Jupiter. It could have continued outward on a path that took it far from the giant planet and back into interstellar space. Instead, its trajectory bends, curves, intercepts Jupiter at a distance that's close enough to be significant, but not so close as to risk capture or destructive tidal forces, That's the sweet spot. The Goldilocks zone for a reconnaissance flyby. Close enough to gather data, far enough to remain safe. Exactly the kind of approach geometry you'd use if you were surveying the solar system and Jupiter was on your checklist. The alternative natural explanation is that we're witnessing selection bias, that interstellar visitors are common, that dozens or hundreds pass through the solar system every year, but we only detect the ones that happen to pass close to major bodies because those are the ones that get bright enough or close enough to trigger our detection systems. That 3i Atlas is unusual, not because its trajectory is special, but because we happen to spot it when most others go unnoticed. There's truth to that. Our detection capabilities are limited. We can only see interstellar objects that come relatively close, or that are unusually bright. The ones that pass through the outer solar system at large distances, never approaching the Sun closely enough to develop visible comas, those remain invisible, undetected. Part of a population we're only beginning to sample. But even accounting for selection bias, the Earth-Jupiter trajectory is statistically peculiar, because it's not just about coming close to one planet, it's about sequencing. Earth first, then Jupiter, inner solar system reconnaissance followed by outer solar system flyby. The kind of itinerary that makes sense if you're gathering comprehensive data about a stellar system, but that seems oddly efficient if it's just random chance. The debate on this point is fierce. Some researchers calculate that the trajectory is, well, within the realm of natural probability once you account for observational biases and the sample size of interstellar visitors we've detected. Others argue that the combination of close approaches to two specific planets on a single pass is rare enough to warrant suspicion. The truth is, we don't have good enough statistics yet to resolve the question. 3 data points, Oumuamua, 2i Borisov, and now 3i Atlas, isn't enough to establish baselines. We don't know what typical interstellar visitor trajectories look like. We don't know whether close approaches to multiple planets are common or rare. We're extrapolating from tiny samples and hoping our conclusions are robust. What we do know is that 3i Atlas is heading toward Jupiter with geometric precision. And when it gets there, when it enters the most intense electromagnetic environment in the solar system, we're going to learn something. Either the object will behave like a passive rock following gravity's pull without any further anomalies, or it will do something, change course, emit signals, exhibit behaviors that natural comets don't display. The electromagnetic environment around Jupiter is unlike anywhere else in the solar system. The planet's magnetic field is enormous, extending millions of kilometers into space and trapping charged particles in radiation belts that would kill an unprotected human in minutes. The field is so strong that it creates intense auroras at Jupiter's poles, light shows visible from Earth through backyard telescopes. It accelerates particles to near-relativistic speeds and creates radio emissions that amateur radio operators can detect. If 3i Atlas interacts with magnetic fields the way it seemed to interact with Earth's ionosphere, then the Jupiter encounter should produce fireworks. Electromagnetic signatures far stronger than the 25 Hz signal we detected at Earth. Radio emissions, X-rays, possibly even visible changes as the object's systems, if it has systems, respond to the massive field environment, or nothing. If the December 19th signal was coincidence, if the electromagnetic coupling we think we saw was actually just atmospheric noise that happened to peak at the wrong time, then Jupiter should be quiet. The object should pass by without any unusual signatures. No signals, no anomalies, just gravity doing its work on a chunk of ice and rock. The difference between those two outcomes will tell us everything. Will either confirm that we're dealing with something beyond our current understanding, or will demonstrate that we've been seeing patterns in noise, reading meaning into randomness, constructing elaborate hypotheses from insufficient data. The waiting is the hardest part. 3 months feels interminable when you're asking questions this fundamental, but the universe doesn't care about our impatience. 3i Atlas will arrive at Jupiter when orbital mechanics dictates it arrives, and not a moment sooner. In the meantime, there's another aspect of this mystery that deserves attention. The visual evidence. The images showing the dark core and luminous ring. Because those images, more than any other single piece of data, are driving the conversation about artificial versus natural origin. When you look at the processed images from December 19th, when you see that perfectly centered void surrounded by a sharp torus of light, your brain immediately recognizes something wrong. This isn't what comets look like. This isn't what natural objects do when you photograph them against the backdrop of space. The standard comet image shows a bright central condensation, the nucleus reflecting sunlight, surrounded by a diffuse coma that fades gradually with distance from the center. Sometimes you see jets, streamers of material shooting out from active regions on the surface. Sometimes you see a tail, the classic feature that makes comets recognizable. But always the nucleus is bright. Solid matter reflects light. That's how we see it. 3i Atlas inverts that completely. The center is dark, absorbing rather than reflecting, and the light comes from a ring, a structure that maintains geometric precision across multiple observation sessions despite the object's rotation. The shadow hypothesis, the idea that we're seeing one part of the object casting a shadow on another part, requires specific geometry. The sun has to be positioned such that light is blocked from reaching the central region while illuminating the edges, and that geometry has to be maintained as the object rotates, which means the rotational axis has to be oriented just right relative to our viewing angle and the sun's position. Possible, but increasingly contrived, because the shadow should move. As the object rotates through its 15.48-hour period, as different parts of the surface come into and out of sunlight, the shadow should shift. It should wobble. It should change shape. But the observations show remarkable stability. The dark core remains centered. The ring remains symmetric. Whatever is creating the structure isn't moving the way a shadow would move. The contact binary model, where 3i Atlas might be two objects touching or orbiting each other very closely, also struggles to explain the observations. Contact binaries are common among asteroids. We've observed many of them. They create distinctive light curves as one lobe eclipses the other during rotation. But they don't create dark cores. You don't see voids. You see irregular shapes, lobes and necks and bulges, but not empty centers surrounded by rings. The hollowness hypothesis fits the observations better than any natural model. If the object is actually a shell, if there's a central void surrounded by a wall of material, then what we're seeing is exactly what you'd expect. The void appears dark because there's nothing there to reflect light. The walls appear bright because they're solid material catching sunlight. And the ring, geometry emerges naturally from viewing a three-dimensional torus-shaped structure in projection. But hollowness creates new problems. Because nature doesn't build hollow shells. Gravity pulls matter together, accumulates it, creates solid bodies or rubble piles where fragments are held loosely together by weak gravity. You don't get voids, you don't get empty centers maintained over long periods, unless the structure is supported, unless there's rigidity, unless the shell has tensile strength sufficient to maintain its shape against the weak but persistent pull of its own gravity. And that requires materials, engineering, design. This is where the artifact hypothesis becomes almost unavoidable. If you accept that the dark core is real, that it's not an optical illusion or viewing geometry effect but an actual structural feature, then you're left with very few natural explanations. You need mechanisms that can create and maintain hollow structures, and those mechanisms are elusive. One proposal is that 3i Atlas might be the remnant of a catastrophic disruption, that it was once a larger body, perhaps a moon or dwarf planet, that was shattered by impact or tidal forces, that what we're seeing is a fragment, a chunk of the original crust that broke off and now exists as a curved shell with nothing inside, that the hollowness is the void left by the missing interior material. It's creative, and it's not impossible, but it requires the fragment to be extraordinarily large and precisely curved. A shell fragment from a planetary-scale body, kilometers across, maintaining its shape despite having negligible gravity to hold it together. And it doesn't explain the luminous ring, which in this model would just be the edges of the shell fragment catching light. Why would the edges be uniformly bright? Why would they create a symmetric ring rather than an irregular boundary? The problems multiply the more carefully you examine the hypothesis. Every natural explanation for the dark core requires adding assumptions and special conditions. Every model needs fine-tuning to match the observations, and collectively, the natural explanations start to feel like epicycles, the increasingly complex adjustments that ancient astronomers made to preserve the Earth-centered model of the cosmos before finally accepting that a sun-centered model was simpler and more accurate. Maybe we're at a similar inflection point with 3i Atlas. Maybe the simplest explanation, the one that requires the fewest ad hoc assumptions, is that the object is artificial, that it was built, that the dark core is a design feature, not a geological accident, that the luminous ring is functional, serving some purpose we don't understand because we don't know what the object is designed to do. If you accept that, if you take the artifact hypothesis seriously, then other pieces fall into place. The rotation change becomes a maneuver. The electromagnetic signal becomes operational, leakage. The trajectory becomes navigation. The Jupiter flyby becomes a planned survey stop. Everything coheres. The anomalies stop being isolated puzzles and become features of a single unified explanation. But that explanation requires accepting something profound and unsettling. That we're not alone, that intelligence exists elsewhere in the galaxy, that it's capable of crossing interstellar space, and that it's here, now, passing through our solar system for reasons we can only guess at. The psychological resistance to that conclusion is massive, because it changes everything: your place in the universe, your sense of uniqueness, your assumptions about the future and the past. If artificial intelligence has visited before, if 3i Atlas is one of many probes that have passed through over Earth's history, then human civilization developed under observation. We weren't alone. We were being watched. And if we're being watched now, then what comes next? Is this just passive observation? Scientific curiosity from beings who are cataloguing the galaxy's biological diversity? Or is there purpose, intention? Are we being evaluated, tested, prepared for something? Those questions spiral quickly into speculation and anxiety, into fears about contact and what it might mean for human autonomy and survival, into hopes about knowledge transfer and technological advancement, and all the possibilities that open up if we're part of a galactic community, rather than isolated on a single world. The emotional weight of those questions is part of why the scientific community is so reluctant to embrace the artificial hypothesis. Because once you open that door, once you accept that we might be looking at technology, the conversation explodes beyond astronomy. It becomes sociology, psychology, philosophy, theology. It becomes about human meaning and purpose and destiny, and those are domains where science has less authority, less certainty, less control over the narrative. Better to stay grounded, to keep the conversation focused on data and observations and testable hypotheses, to demand evidence that meets rigorous standards before making claims that would upend the worldview of billions. And that's appropriate. That's how science should work. Conservative in its claims, rigorous in its methods, resistant to extraordinary conclusions until the evidence becomes overwhelming. But there's a balance between appropriate skepticism and willful blindness, between demanding sufficient evidence and refusing to acknowledge evidence that's already available, between being careful and being closed-minded. 3i Atlas is pushing us toward that balance point. The anomalies are real. The observations are documented. Multiple independent teams are seeing the same things. The data exists. The question is how to interpret it, whether to accept natural explanations that require increasingly specific conditions, or to seriously consider the artificial alternative even though it carries enormous implications. The Jupiter encounter will help. Will provide another data point, another test of whether the patterns we're seeing are robust or coincidental. If the object interacts with Jupiter's magnetosphere the way it seemed to interact with Earth's ionosphere, if we see electromagnetic signatures consistent with the 25 Hz signal, but scaled up by Jupiter's much stronger field, then the case for artificial origin becomes much stronger, becomes difficult to dismiss even for the most conservative researchers, and if nothing happens, if the Jupiter flyby is electromagnetically quiet, then maybe we can accept that December 19th was an outlier, a fluke, a random atmospheric event that coincided with the closest approach but wasn't actually caused by it, that the dark core is an optical illusion we'll eventually explain, that the rotation change had some exotic natural cause we haven't identified yet, but that doesn't require invoking technology. Either outcome provides information. Either way, we learn something about what 3i Atlas is and how it interacts with its environment. Either way, the mystery moves toward resolution, but resolution might not mean answers, might not mean certainty. Because even if the Jupiter encounter shows nothing unusual, the December 19th observations remain. The 25 Hz signal happened. The rotation change occurred. The dark core was photographed. Those facts don't disappear just because subsequent observations are less dramatic. We might end up in a position where the data remains ambiguous even after all the observations are complete, where natural and artificial explanations both remain plausible, where we can't definitively prove which interpretation is correct. And if that happens, if we're left with uncertainty, how do we respond? How does humanity process the possibility, even if unconfirmed, that we might have been visited? The answer to that question will vary. Some people will embrace the possibility, will see it as confirmation of beliefs they've held for years, will feel validated that the search for extraterrestrial intelligence has finally borne fruit, even if the fruit is ambiguous and contested. Others will reject it, will insist that without definitive proof, the artificial hypothesis is just speculation, will argue that accepting it prematurely does damage to the scientific enterprise and to public understanding of how science works, and most people will probably land somewhere in the middle, intrigued by the possibility, uncertain about the evidence, waiting to see what additional data emerges and whether consensus eventually develops. That's the position we're in now, 3 months before the next major event. 3 months of watching and waiting and arguing and analysing, 3 months of uncertainty punctuated by occasional new observations as 3i Atlas continues its journey through the inner solar system. The object is currently between Earth and Jupiter, moving outward at 58 kilometers per second. Each day carries it roughly 5 million kilometers farther from us and closer to the giant planet. Telescopes continue to track it. Spectrometers continue to analyze the light reflecting from its surface. Radio telescopes listen for any signals, any transmissions, any electromagnetic activity beyond what natural processes would produce. So far, since December 19th, the object has been quiet. No additional electromagnetic anomalies, no further rotation changes. The dark core persists in images, but it's not doing anything, not changing, not evolving, just maintaining its enigmatic presence as the object speeds outward. That quietness is itself interesting. If 3i Atlas were actively outgassing, if natural sublimation were driving the behaviour we saw at Earth, you'd expect ongoing activity. Continuous changes as different parts of the surface receive varying amounts of solar radiation, but the object appears stable, dormant. Like whatever activated during the Earth encounter has been shut down again. That's consistent with artificial operation, a probe executing a scheduled manoeuvre, collecting data, then returning to passive mode until the next planned activity. It's also consistent with natural processes that are highly temperature dependent, where activity only occurs during specific thermal conditions that don't exist anymore now that the object has moved farther from both Earth and the Sun. Ambiguity. Everywhere you look, ambiguity. Multiple explanations for every observation. Uncertainty pervading every conclusion. It's frustrating for researchers who want clear answers, and for the public that's following the story and trying to understand what's actually happening. But ambiguity is often the state of science at the frontier. When you're observing something genuinely new, something outside your previous experience, you don't immediately know what you're looking at. You collect data, you build models, you test predictions, and gradually, over months or years, clarity emerges. Patterns become apparent, explanations gain support or fall away, understanding develops. We're in the early stages of that process with 3i Atlas. We've only been observing it for 5 months, only had close-range data for a few weeks. It's unreasonable to expect definitive conclusions on that timescale. What we have are intriguing observations, anomalies that need explanation, questions that demand investigation. The Jupiter encounter is the next milestone, the next opportunity to gather concentrated data under conditions different from anything we've observed so far. And depending on what we see, the trajectory of this investigation will shift. We'll either move toward confirmation that something extraordinary is occurring, or toward acceptance that we've witnessed unusual but ultimately natural phenomena. March 16th, 2026. That's the date to watch. That's when the next chapter begins, when 3i Atlas reaches its closest approach to Jupiter, and we see whether the patterns established at Earth repeat or disappear. Until then, the work continues. Observations accumulate, models improve, hypotheses are refined and tested against new data, and the debate rages on in journals and conferences and online forums, with researchers and enthusiasts and skeptics all contributing perspectives and arguments and interpretations. Because this is how science processes the unknown. Not through sudden revelation, but through sustained effort, through accumulating evidence and building consensus gradually, through testing and checking and questioning and revising. 3i Atlas is teaching us that process. teaching us humility about how much we don't know and how difficult it is to interpret observations when you don't have good frameworks to place them in, teaching us that the universe still has surprises, that despite centuries of astronomy and decades of space exploration, we can still encounter phenomena that challenge our understanding. And whether the object is natural or artificial, whether the anomalies have exotic but conventional explanations or require invoking technology, the lesson is the same. We're not done learning, we're not done discovering. The cosmos is larger and stranger than our models encompass. The dark core stares outward. The rotation holds steady at its new, faster rate. The electromagnetic silence continues, and 58 kilometers per second, the object speeds toward Jupiter, carrying questions we've asked and secrets we haven't yet imagined. 3 months. Just 3 months until we see whether the mystery deepens or resolves. Until we get another data point in the most important observational campaign of the decade. Until we learn whether 3i Atlas is an anomaly or a herald. The waiting is difficult, but the work continues. And when March arrives, when the object enters Jupiter's domain and either responds or remains silent, we'll be watching. Every telescope we can point at the encounter, every detector we can bring to bear, every analytical tool we've developed. Because this matters, whether it's natural or artificial, whether it confirms our place as alone in the cosmos or hints at a populated galaxy, whether it expands our understanding of comets or rewrites our assumptions about what's possible, this matters. This is the kind of observation that defines eras. That becomes a reference point for future research, that people will study and debate for generations, and we're living through it, watching it unfold in real time, participating in the investigation and the conversation. We're the generation that encountered 3i Atlas, that documented the anomalies, that asked the hard questions about what we're actually seeing. The object continues outward, the mystery continues to deepen, and the countdown to Jupiter continues to tick. 3 months minus the week since December 19th. Roughly 10 weeks remaining. 70 days until the next encounter. Until the next test. Until we learn whether the patterns hold or break. And whatever we learn, whatever the data shows, it will be another step toward understanding. Another piece of the puzzle. Another movement in the ongoing symphony of human curiosity reaching out to comprehend the cosmos. The dark core waits. Jupiter waits. And we wait, watching and wondering what secrets will be revealed when the visitor reaches the king of planets and the electromagnetic environment reaches intensities that dwarf anything Earth could produce. The signal will either return, amplified and unmistakable, or it will remain silent. The object will either maneuver again or continue on its gravitational trajectory unchanged. The mystery will either deepen beyond recovery or begin to resolve into something we can understand. 3 months to discovery, 3 months to answers, 3 months until we know whether December 19th, 2025 was the date when humanity detected its first confirmed visitor from beyond, or just another day when we learned that the universe is stranger than we thought, but still fundamentally knowable through the tools of science. The heartbeat changed once. Will it change again? Will Jupiter's massive field create resonances that Earth's weak ionosphere could only hint at? Will we see electromagnetic signatures that leave no doubt about the object's nature? Or will we see nothing? Will the flyby be quiet, unremarkable, a simple gravitational interaction between a comet and a planet? Either answer teaches us something. Either way, we learn. Either way, the frontier of knowledge expands. But only one answer changes everything. Only one outcome means we're not alone. Only one result confirms that the galaxy is populated and that we've just had our first documented encounter with technology from elsewhere. March 16th will tell us which universe we live in, the one we've always assumed we inhabited, where humanity is unique and isolated and alone. Or the one we've always hoped for, where intelligence is common and the cosmos is filled with minds and machines exploring and learning and reaching across the light years to touch civilizations not their own. 3 months, the object speeds onward, the mystery remains, and we watch and wait and wonder what the dark core will reveal when it finally reaches its destination and the test begins anew. The biological responses started appearing in social media within hours of the December 19th closest approach. Anecdotal reports scattered across platforms from people who had no knowledge of 3i Atlas or the 25 Hz electromagnetic anomaly. Headaches, anxiety, a pervasive sense of unease that peaked in the afternoon and evening, and then gradually subsided. Sleep disturbances, vivid dreams, animals behaving strangely, dogs barking at nothing, birds roosting at unusual times, pets displaying anxiety their owners couldn't explain. Individually, these reports mean nothing. People get headaches every day. Anxiety is common. Sleep patterns fluctuate. Animals are unpredictable. You can find anecdotal reports of unusual symptoms and behaviors on any date if you look hard enough. The human tendency to notice coincidences and construct patterns from random noise is powerful and well documented. But the volume of reports on December 19th was statistically unusual. Social media analytics, the algorithms that track trending topics and sentiment analysis, flagged the day as anomalous. Not dramatically, not in ways that triggered news coverage or official responses. Just enough that researchers looking at the data afterward noticed a small but measurable spike in reports of these specific symptoms clustering around the time window when Earth's electromagnetic field was resonating at 25 Hz. The mechanism, if there is one, would be subtle. The Schumann resonance, Earth's natural electromagnetic baseline, has been studied for decades in relation to biological systems. Some research suggests that organisms, particularly humans, are sensitive to these frequencies, that our circadian rhythms, our neurological activity, even our cardiovascular systems might be entrained to Earth's electromagnetic environment in ways we're only beginning to understand. The fundamental Schumann frequency, 7.83 Hz, falls within the range of human brainwave activity. Specifically, it's in the alpha wave band, associated with relaxed but alert states. Some researchers have proposed that this isn't coincidence, that life evolved on a planet with this electromagnetic baseline and adapted to it. That our biology incorporates and responds to these frequencies because they've been present throughout evolutionary history. If that's true, if there's coupling between Earth's electromagnetic field and biological systems, then a sudden shift to a different dominant frequency might cause disruption, might create the kinds of symptoms people were reporting. Headaches from neurological systems trying to synchronize with an unfamiliar frequency. Anxiety from autonomic nervous system responses to environmental changes. Sleep disturbances from circadian mechanisms being thrown off their normal rhythm. It's speculative. The research linking Schumann resonance to biology is controversial. Many neuroscientists dismiss it as pseudoscience, arguing that the electromagnetic fields involved are far too weak to meaningfully influence neural activity, that any correlations are coincidental or the result of poorly controlled studies. But some of the research is credible, conducted by reputable scientists using proper methodologies, showing statistically significant correlations between Schumann resonance variations and measurable physiological parameters, heart rate variability, brainwave patterns, circadian markers, not overwhelming effects, not the kind of dramatic influence that would be obvious without careful measurement, but detectable, present in the data, and if those subtle influences exist normally, then a dramatic shift to a non-standard frequency like 25 Hz might produce more pronounced effects, might cross thresholds where weak coupling becomes noticeable, where the background hum of Earth's electromagnetic field, usually imperceptible, becomes something organisms can feel even if they can't consciously identify what they're feeling. The 25 Hz frequency itself is interesting from a neurological perspective. It falls in the beta wave range, associated with active thinking, focus, and alertness. It's the brain state of concentration and cognitive engagement. If Earth's electromagnetic field suddenly shifted to resonating at beta frequencies, if that signal coupled to human neural activity the way the normal 7.83 Hz baseline might, you'd expect heightened arousal, increased neural activity, possibly anxiety if the stimulation was strong enough, or occurred at inappropriate times like during sleep. None of this proves causation. The biological reports could be completely unrelated to the electromagnetic anomaly, could be mass psychogenic effects, people experiencing symptoms because they heard about the comet Flyby and expected to feel something, could be random variation that happened to occur on the same day for reasons having nothing to do with 3i Atlas, but the timing is suggestive. The correlation exists. And if the mechanism is real, if biological systems did respond to the 25 Hz signal, then we have confirmation that 3i Atlas didn't just affect Earth's electromagnetic field, it affected life. It reached across 270 million kilometers and touched the biosphere in measurable ways. That's profound if true, because it means the interaction wasn't just physical, It was biological, an interstellar visitor, whether natural or artificial, interfacing with Earth's living systems through electromagnetic coupling, creating responses in organisms that evolved under a completely different electromagnetic baseline and that suddenly found themselves exposed to frequencies from outside the solar system. And if it happened at Earth, it could happen at Jupiter. The biological angle is less relevant there because Jupiter has no surface life, no biosphere to respond. But the electromagnetic environment is vastly more intense. If coupling exists, if 3I Atlas interacts with magnetic fields in ways that create detectable signatures, then Jupiter's magnetosphere should produce effects that dwarf anything we saw at Earth. Jupiter's magnetic field is the strongest planetary field in the solar system, thousands of times more powerful than Earth's. It extends millions of kilometers into space, creating a magnetosphere so large that if you could see it from Earth, it would appear larger than the full moon. The field traps charged particles, creating radiation belts that are lethal to spacecraft electronics and any biological organisms unfortunate enough to enter them. The field also creates emissions. Jupiter is a radio source, broadcasting across a wide spectrum of frequencies as charged particles spiral through the magnetic field lines and emit synchrotron radiation. Amateur radio operators can detect these emissions. The signals are strong enough, distinctive enough, that Jupiter is one of the most prominent radio sources in the sky despite being so far away. If 3I Atlas interacts with magnetic fields electromagnetically, if the 25 Hz signal at Earth was a real coupling effect and not coincidence, then the object's passage through Jupiter's magnetosphere should create electromagnetic fireworks, radio bursts, variations in Jupiter's natural emissions, possibly new frequency components that appear only during the flyby and then fade away as the object exits the field. Researchers are preparing to monitor Jupiter across every available wavelength during the March 16th encounter. Radio telescopes will be listening. Optical telescopes will be watching for auroral changes or atmospheric disturbances. X-ray observatories will look for high-energy emissions. And magnetometers on spacecraft orbiting Jupiter or passing through the system will measure any variations in the field strength or configuration. If the coupling hypothesis is correct, if 3I Atlas generates or responds to electromagnetic fields in unusual ways, March 16th should provide undeniable evidence. The signals should be strong, unmistakable, repeated across multiple independent detection systems, and if nothing happens, if Jupiter's magnetosphere remains unchanged and the radio emissions show no anomalies, and the object passes by without creating any detectable electromagnetic signature, then the 25 Hz signal at Earth becomes much harder to defend as real coupling, becomes more likely to have been atmospheric noise, random variation that coincided with the flyby but wasn't caused by it. The stakes for March 16th are therefore enormous. It's not just another observational opportunity, it's a test, a deliberate natural experiment where the conditions are different enough from Earth that the results will be informative regardless of outcome, either confirming the coupling hypothesis or refuting it, either demonstrating that 3I Atlas has electromagnetic properties beyond what natural comets display, or showing that December 19th was an outlier that won't repeat. The scientific papers are already being drafted. Researchers on both sides of the debate are preparing manuscripts that will be submitted within days of the Jupiter encounter. Papers arguing that the data confirms artificial origin. Papers arguing that natural explanations remain sufficient. Papers proposing new observational campaigns to gather additional data. Papers calling for missions to chase down the object before it leaves the solar system, because time is running out. 3I Atlas will pass Jupiter on March 16th. We'll continue outward, crossing the orbits of Saturn, Uranus, and Neptune over the following years. By 2030 it will be in the Kuiper Belt, too distant for detailed observation. By the mid-2030s it will be beyond our detection capabilities entirely, lost in the interstellar dark from which it came. This is our window, the few years while it remains visible, the short period when we can still point telescopes at it and gather data. Once it fades from view, once it's gone, we'll never see it again. We'll be left with whatever observations we manage to collect and whatever conclusions we can draw from that limited data set. The pressure to make those observations count is intense, to extract maximum information from every photon, to coordinate international efforts so that coverage is comprehensive and redundant, to make sure that when 3I Atlas finally disappears, we've done everything possible to understand what it was and what it meant, Some researchers are advocating for a more direct approach, a mission, a spacecraft to intercept the object before it leaves. The technology exists barely. A probe launched on a heavy-lift rocket using gravitational assists from Earth and Jupiter could potentially catch up to 3I Atlas sometime in the late 2020s or early 2030s. The delta-V requirements are enormous. The mission would be expensive and risky, but it's possible. The scientific return would be transformative. Close-up imaging that resolves surface features at meter scale rather than kilometer scale. In-situ measurements of composition, magnetic fields, particle emissions, potentially even sample collection if the probe could match velocity and approach closely enough. Direct answers to questions that spectroscopy and remote observation can only address indirectly. If 3I Atlas is natural, if it's a strange but ultimately conventional comet, those answers would expand our understanding of interstellar objects and the diversity of planetary formation processes in other stellar systems. Valuable science. Worth the investment. If it's artificial, if the anomalies we're seeing are evidence of technology, then the scientific return becomes incalculable. Physical contact with extraterrestrial artifacts, material samples that could be analysed for composition, structure, manufacturing processes, potentially even functional components if parts of the probe remain operational. Knowledge that could advance human technology by decades or centuries. Confirmation that we're not alone and that intelligent life exists elsewhere in the galaxy. The decision about whether to launch such a mission is being debated in space agency boardrooms and government offices. Budget considerations, political will, risk assessment. The timeline is tight. If a mission is going to happen, it needs to be approved and funded soon. Spacecraft take years to design and build. Launch windows are constrained by orbital mechanics. By the time 3I Atlas reaches Jupiter, the decision will likely have been made. Either a mission will be in development, moving forward on an accelerated timeline to catch the object before it escapes, or the opportunity will have been deemed too expensive, too risky, not justified by the ambiguous evidence we have so far. That's the tragedy of dealing with phenomena at the edge of detection. The evidence is always incomplete, the data is always ambiguous, and the decisions about how much to invest in gathering better data have to be made before you know whether the investment will pay off. If we don't chase 3I Atlas, if we let it go and then later observations or theoretical work suggest we missed something profound, the regret will be immense. Future generations will look back and ask why we didn't act when we had the chance. Why we allowed caution and budget constraints to prevent us from investigating what might have been the most important discovery in human history. But if we do chase it, if we commit billions to a mission, and the object turns out to be a natural comet with exotic but conventional properties, then the resources will have been spent on something less transformative than other possible missions, other targets, other scientific priorities. The gamble is unavoidable. Science at the frontier always involves gambling, betting resources on uncertain outcomes. Sometimes you win and make discoveries that justify the investment many times over. Sometimes you lose and learn something, but not enough to warrant the cost. With 3I Atlas, the stakes of that gamble are unusually high, because the potential payoff, if the artifact hypothesis is correct, is so enormous that even a low probability might justify the attempt. But the cost is real. The opportunity cost of not pursuing other missions with more certain returns. Space agencies are accustomed to these calculations. They make them constantly, weighing competing proposals and trying to allocate limited budgets to maximize scientific return. But this decision is complicated by the fact that the questions aren't purely scientific. They're philosophical, sociological, about human priorities and values and what we think is worth knowing. Is confirming that we're not alone worth more than understanding the composition of Europa's ocean or the chemistry of Titan's lakes? Is the possibility of contact with extraterrestrial technology worth delaying missions to study exoplanets or search for biosignatures on Mars? There's no objective answer, no formula that balances these considerations. In the end, it comes down to judgment, to the collective decision-making of scientists and administrators and politicians about what matters most and what we're willing to invest in finding out. The March 16th encounter will inform that decision. If Jupiter produces dramatic electromagnetic signatures that confirm coupling, if the object maneuvers again or exhibits clear non-gravitational acceleration, the case for a mission becomes overwhelming. The evidence shifts from ambiguous to Compelling. The investment becomes justified. If Jupiter is quiet, if the encounter passes without incident, the case weakens. Becomes harder to justify the expense on the basis of a single anomalous event at Earth that might have been coincidence. So everything rides on March 16th. The observational campaign, the data interpretation, the conclusions that emerge from analysing the results, the decisions about future missions and priorities. All of it depends on what happens when 3I Atlas passes through Jupiter's domain and either confirms the patterns we've seen or demonstrates that they don't repeat. The countdown continues. The object speeds outward, 58 kilometers per second, every second bringing it closer to the encounter and farther from the opportunity to change course if we decide to chase. And in the background, the larger questions loom about what 3I Atlas represents, about whether we're witnessing natural phenomena we don't yet understand or something that requires expanding our assumptions about what exists in the cosmos. The dark core hypothesis, the idea that the object is hollow, remains the most visually striking piece of evidence. Because images are powerful, people can see the dark center and the luminous ring and immediately recognize that something is unusual. It doesn't require understanding spectroscopy or electromagnetic coupling or orbital mechanics. It's just wrong in an obvious visceral way. If the object is hollow, if that's a real structural feature and not an artifact of viewing geometry, then the question becomes how and why. How does a hollow structure form naturally? What processes create and maintain voids in kilometre-scale bodies? The answers remain elusive. Every natural mechanism proposed has problems. Impact fragmentation creates rubble, not shells. Differential rotation can't hollow out an interior without leaving visible evidence of the process. Exotic chemistry might explain unusual surface properties but doesn't create internal voids. The artificial explanation remains simple. Hollow structures are easy to build if you have engineering. Shells have advantages for spacecraft design. They minimize mass while maximizing volume. They provide space for payloads and systems. They can be rigid and stable while using less material than solid bodies. If 3I Atlas is a probe, if it was built rather than accreted, then the hollow core makes perfect sense. It's a design choice. Intentional, functional. The void is there because that's where the instruments and computers and power systems reside. The shell is the hull, the protective barrier between the interior and the harsh environment of space. And the luminous ring could be thermal. Heat from internal systems radiating through the hull and creating the bright signature we observe. Or it could be active venting, material being expelled from the rim as part of propulsion or attitude control. Or it could be something else entirely, some function. We can't identify because we don't know what the probe is designed to do. This is the challenge of interpreting potential artifacts. If you're looking at something natural, you can apply known physical laws and chemical principles and work out what it is and how it formed. The answers might be complex, but the framework is established. If you're looking at something designed, the framework breaks down, because design is about purpose, about achieving specific goals through engineered solutions. And without knowing the goals, without understanding what the artifact is for, you can't reverse engineer the design choices. A probe from another civilization might operate on principles we understand, but apply them in ways we haven't considered. Or it might use physics we haven't discovered, exploit phenomena we don't know exist. The range of possibilities is limited only by what's physically possible in the universe, which is a much larger space than what human technology has explored. This is why the artifact hypothesis is so difficult to prove or disprove, because almost any observation can be explained either way, either as exotic natural processes we don't fully understand or as artificial technology operating in ways we can't identify. The ambiguity is inherent when you're trying to recognize intelligence in systems that might be completely unlike human intelligence. The best approach is probably to gather as much data as possible and let the evidence accumulate until patterns emerge that favor one interpretation over another. And that's what the observational campaigns are designed to do, to document everything, to measure precisely, to build data sets that future researchers can analyze with better tools and better frameworks. Because even if we can't definitively answer the question of whether 3I Atlas is artificial during its passage through the solar system, the data we collect will be valuable for decades. Will be studied and reanalyzed as our understanding improves. Will eventually yield insights that aren't apparent now because we don't have the context or the theoretical frameworks to recognize them. The history of science is full of observations that weren't understood until much later, data collected for one purpose that turned out to be crucial for answering completely different questions. Archives that seemed mundane when created but became invaluable when new theories emerged that could explain previously mysterious features. 3i Atlas might be one of those cases. The observations we're making now, the spectra and images and trajectory measurements, might not fully make sense until we've encountered more interstellar visitors, until we've built up enough examples to see patterns, until we've developed theories that can account for the diversity of objects passing through the solar system. Or the answers might come sooner. March 16th might provide clarity, might give us that one crucial observation that tips the balance and makes the correct interpretation obvious. The uncertainty is frustrating but also exhilarating, because it means we're at the frontier. We're dealing with something genuinely unknown. Not a puzzle where the pieces just need to be arranged correctly, but a mystery where we don't even know what all the pieces are yet. And that's what makes this moment special, what makes 3i Atlas worth all the attention and resources and debate. Because regardless of whether it's natural or artificial, it's shown us that the universe still has surprises, that despite centuries of astronomy, we can still encounter phenomena that don't fit our categories and that force us to expand our thinking. The object continues outward. The dark core maintains its enigmatic presence. The rotation holds steady at 1548 hours, the new rhythm established during the Earth encounter and maintained ever since. And the electromagnetic silence continues. No signals detected since the 25 Hz anomaly faded in the days after December 19th. That silence is almost as interesting as the signal was, because if the object is artificial, if it's a probe executing a mission, the silence suggests it's between active phases. It did something at Earth, scanned, transmitted, maneuvered, and now it's dormant again, conserving resources or waiting for the next programmed event. If it's natural, the silence is expected. Cometary activity is episodic. Objects brighten and dim. Outgassing varies with distance from the sun and with local heating conditions. Quiet periods are normal, but the pattern, active at Earth and quiet afterward, has a designed feel to it. Like a system that turns on when needed and turns off when not. Like intentional operation rather than random variation. This is the kind of detail that drives the debate. Small observations that could be interpreted either way but that collectively create an impression. A sense that something about 3i Atlas is too organised, too purposeful, to be entirely natural. And yet, nature creates order. Crystal structures are geometric. Planetary orbits are ellipses. DNA is a double helix. Organisation emerges from physical laws without requiring design. So seeing patterns, seeing apparent purpose, doesn't necessarily mean intelligence is involved. The line between natural order and designed order is blurrier than we'd like to admit, especially when dealing with complex systems operating at scales where our intuitions aren't reliable. The safest position is probably to remain agnostic, to acknowledge that the evidence is ambiguous and that both natural and artificial explanations remain viable. To wait for more data before committing to conclusions that might be difficult to walk back if future observations contradict them. But agnosticism is unsatisfying. Humans want answers. Want to know whether we're alone or part of a larger galactic community. Want to understand what 3i Atlas is and what its passage through our solar system means. And so the debate continues, will continue through March 16th and beyond. Will persist until either overwhelming evidence settles the question, or until 3i Atlas fades from view and the mystery becomes something for future generations to solve with better technology and more complete datasets. The legacy of 3i Atlas, regardless of what it turns out to be, is already significant. It's forced us to take seriously questions we've been avoiding. Questions about how to recognize artificial objects, about what interstellar visitors might look like, about whether we're prepared for contact if it occurs. It's revealed gaps in our observational capabilities and our theoretical frameworks, shown us that we don't have good models for how interstellar comets should behave or what electromagnetic signatures they might produce, demonstrated that our sample size is too small and our experience too limited to be confident about what's normal and what's anomalous, and it's reminded us that space is not empty, that the galaxy is dynamic, that objects move between stars, carrying information about distant systems and potentially about distant minds. That isolation is an illusion, and that we should expect visitors, whether natural or otherwise. The next interstellar object will arrive eventually, maybe years from now, maybe months. We don't know the rate well enough to predict, but when it comes, we'll be more prepared than we were for 3I Atlas. We'll have protocols, experience, frameworks for rapidly characterizing the object and deciding whether it warrants intensive study. We'll compare it to 3I Atlas. Look for similarities and differences. Start to build that statistical sample that will eventually tell us what's typical for interstellar visitors and what's genuinely unusual. And maybe that next object will be unambiguous, will be so clearly natural or so clearly artificial that the debate ends and we move forward with certainty. Or maybe it will be just as ambiguous as 3I Atlas, adding to the mystery rather than resolving it. Either way, the age of interstellar visitor detection has begun. 3I Atlas is the third confirmed example. There will be fourth, a fifth, dozens, hundreds as our observational capabilities improve. The solar system is a busy place. We're just starting to notice. And as we notice, as we catalogue and study and try to understand, we're building knowledge that will serve humanity for generations. Knowledge about the galaxy we inhabit, about the diversity of objects and processes operating at scales beyond single stellar systems, about what's possible in the cosmos, and what might be waiting for us when we finally develop the capability to travel between stars ourselves. 3I Atlas is a messenger. Whether it carries a deliberate message or just information encoded in its composition and behaviour doesn't change its value. It's brought us data from beyond, challenged us, made us think harder and look closer and question assumptions we didn't know we were making. And now it speeds toward Jupiter, carrying those questions with it, carrying the mystery toward its next test, toward the encounter that might provide answers or might deepen the enigma beyond resolution. March 16th, 2026. Mark it. Remember it. Because that's the date when we'll learn whether the patterns established at Earth are robust or coincidental, whether the coupling hypothesis survives or fails, whether the artifact interpretation gains support or loses credibility. That's the date when the dark core enters the strongest magnetic field environment in the solar system and either responds in ways that confirm its exotic nature or passes through silently, demonstrating that whatever it is, it doesn't interact with magnetic fields in the ways we've theorized. That's the date when 3I Atlas either confirms it's something extraordinary or begins its transformation into just another entry in the catalogue of unusual but natural objects that have passed through the solar system over Earth's history. The countdown continues, the observations accumulate, the debate intensifies, and the object itself, indifferent to our questions and our theories and our hopes and fears, continues its ancient journey across the galaxy. It came from the dark, it passed through our light, and soon it will return to the dark, leaving us with more questions than answers, but also with more knowledge than we had before it arrived. That's the nature of the frontier. That's what it means to explore the unknown. You don't always get resolution, you don't always get certainty, but you always get something, some increment of understanding, some expansion of the possible. 3I Atlas has given us that, has expanded our sense of what's possible, has shown us that the universe can still surprise us, that the space between stars isn't empty but populated with travellers carrying stories we're only beginning to learn how to read. And when the next traveller arrives, when the next interstellar visitor enters our detection range and triggers our instruments and captures our attention, we'll be ready. More ready than we were this time, better equipped, more experienced, more capable of asking the right questions and designing the right observations. The journey of discovery continues, the mysteries multiply, and somewhere in the data, in the spectra and images and electromagnetic signatures, truth waits to be found. The dark core stares. The heartbeat that changed Earth's rhythm for hours on December 19th has fallen silent, and the object speeds toward Jupiter at 58 kilometers per second, carrying its secrets toward the next revelation. 3 months became weeks, weeks are becoming days, and soon, very soon, we'll know. We'll see what happens when the visitor reaches the giant planet, and the strongest magnetic environment in the solar system either responds to its presence or remains indifferent. We'll see. Whether the 25 Hz signal was a harbinger of something profound, or just an atmospheric fluke that won't repeat. Whether the dark core represents engineering or geology. Whether the rotation change was a maneuver, or outgassing we don't understand. We'll see whether we're alone, or whether the galaxy has sent us a messenger. silent and enigmatic, carrying information we're only beginning to decode. The answer is coming. The data will flow. The truth, whatever it is, will emerge. And humanity will face that truth, whatever it means for our place in the cosmos, whatever it implies about the future and about what's waiting for us in the vast spaces between stars. The visitor came. The visitor challenged us. And soon the visitor will either confirm our deepest hopes or our most conservative assumptions. Either way, we'll never look at the sky the same way again. Either way, 3i Atlas will have changed us. The dark core watches. Jupiter waits, and we hold our breath, counting down to the moment when mystery either transforms into knowledge or deepens into something that might take generations to fully understand. The heartbeat of Earth returned to normal, but the memory remains, the 25 Hz tone that shouldn't exist, the signal that appeared and faded and left us wondering whether we heard the voice of the cosmos or just our own hopes echoing back at us. Soon we'll know. Soon the universe will answer, and whatever that answer is, we'll be listening.